Good afternoon. So we are now starting with the chapter called as histogram and cumulative frequency diagram. What is the histogram? This is a sample of histogram. What do we see? We have seen bar graph before. So this is nothing but a bar graph. It's just that in the bar graph you can make a graph here. For example, I'll show it here. Do we have it? Yeah. So I could make a bar graph like this, where there is one graph here, and the second bar will be written or will be shown with some gap in between, and this gap can be anything. And let's say I write January here, and this is for February. There is certain data for January, February, March, April, or can be data for Monday, Tuesday, Wednesday, and we are showing bar graphs with gaps in between. Histogram does not have gaps in between. The histograms show that the numbers on x-axis are also continuous and the numbers on y-axis are also continuous. On the bar graph, the numbers on x-axis or whatever that we are showing, the data on x-axis may not be continuous, and we do not show it as continuous as well. It can be that some some player has so many goals. So player 1 P1 and this is player 2 P2. Now there is nothing continuous about it. You can have gaps in between that. But the first graph is starting from 0 to 50 and from 50 to 65 is the second graph. Now what is happening is the first entire value or entire class is ending at 50 and the second one is starting at 50. So there has to be continuity. We cannot avoid that. We cannot keep random gaps in between. So this is the only difference between the bar graph and the histogram. Let's carry on. We can see the histogram, we can interpret the histogram. The speed is from 0 to 50 and this speed is much less. So the speed from 0 to 50 and the frequency density is much less. What is frequency density? Frequency density is defined as the frequency divided by the width of the class. Here the frequency density is quite high. Here it is high. It is very high here. It is slightly lesser here, but still high enough. But the reason why these frequency densities are high is because of course the frequency will be high, but also the width of the class is much lesser. Here the width of the class was far greater and the frequency density is frequency upon class width. This is the formula. So eventually you understand what is happening here. Let's take some example here, this one. Let's see the work example. The class starting from 5 to 15, height in centimeter, number of plants. We have certain plants in a nursery and we are checking how many plants are having height from 5 to 15, 15 to 20, 20 to 25, 25 to 40 and so on. So the number of plants are 4, 8, 7 and 6. The total is 4, 8, 12 and this is 13. 25 plants are there. Out of 25 we are checking 5 to 15 centimeter would be the height of 4 plants, 15 to 20 is for 8 plants, 20 to 25 is for 7 plants and 25 to 40 centimeter is the height of 6 plants. Now let's just convert this into the frequency density and then we'll plot the appropriate histogram. So 5 to 15 the number of plants is 4 and the 5 to 15 the class width is upper limit minus lower limit is 10. 15 minus 5 will be 10. The number of plants is 8 for the second class and the class width is 5. Class width is 5 again and the number of plants is 7. And the class width here is 15 and the number of plants is 6. Now we will do frequency density is the frequency divided by the class width. 4 upon 10 is 0.4. 8 upon 5 is 1.6. 7 upon 5 is 1.4. 6 upon 15 is 0.4. And that has been plotted on the graph like this and the histogram is ready. 0 to 5 there is nothing. 5 to 15 and we showing height equal to 0.4. 15 to 20 1.6. 1.5 1.6. 20 to 25 1.4 and 25 to 40 is 0.4. So this is histogram. This is how you plot a histogram. Again, exercise. I don't want to get into this now. It is just very simple. Just calculate the class width. This class width will be 200 minus 100, that is 100. So let's write this quickly. So here it is class width and this is frequency density. Class width here is 100. It is 50 next, 50 again, 50 again, 50 again and 100 in the end. Frequency density is 18 upon 100 is 0.18. 18 upon 50 is 0.36. 32 upon 50 is 0.64. 31 upon 50 is 0.62. 21 by 50 is 0.42. And 20 by 100 is 0.20. And then just show it on the graph using the histogram. Mass in kilogram and frequency. It's just same thing again and again. Now this question will do because this question is about interpretation of the histogram. We are not asked to draw the histogram. Histogram is given. We are asked to find out the meaning of it. Let's make the sense out of it. A group of personal trainers at a gym were given fitness tests where the percentage body fat was calculated. The fitness assessor drew this histogram of the result. So whoever was assessing the fitness level, body fat, has come to this conclusion. And the conclusion is 4% to 24% of body fat is satisfactory. Beyond that, it is worrisome. How many personal trainers were tested? The number of personal trainers are, this is, let's see, percentage body fat, this is number of personal trainers. Okay, so this is 4 to 8 will be, this is I think 3. It is slightly above the halfway mark. So halfway mark between 0 to 5 will be 2.5. So it is slightly more, is 3. This is 20, this is also 20, this is also 20. So 3, 23, 43, 63. This is 10, 73. 5, 73 plus 5 will be 78. And this should be 1 and 1. So 2, 78 plus 2 is 80. So 80 personal trainers were tested. How many personal trainers have bad body fat within the satisfactory limits? Within the satisfactory limit is 3 plus 20, 20, 20, 63 plus 10 is 73. So 73 personal trainers have body fat within the satisfactory limits. How many personal trainers had levels which were too high? 7 of them. 5 plus 1 plus 1, 7. What do you think? Why do you think there is no bar in 0 to 4 category? There is no bar between 0 to 4 category because the frequency will be 0. The number of trainers are 0. So 0 number of people have body fat percentage from 0 to 4%. Everybody's body fat is more than 4%. So that's why there is no graph here. Would you expect a similar distribution if you tested random selection of people in your community? Give a reason for your answer. My answer is, would I expect similar distribution? No. Because these are trainers, personal trainers. And it is expected that the people who are training others about the weights and the physical health that you maintain and the gym that you visit, there are certain trainers, and the trainers are often in the habit of keeping themselves fit. But normal people are not like this. So this may completely be opposite. 73 out of 80 are having satisfactory body fat. In a normal situation, if you are not talking about trainers and anybody in this world, this might be absolutely opposite. 73 out of 80 might be having far too much of body fat. I'm just guessing, I'm not casting aspersion, but I'm saying I don't expect the same kind of distribution. Will not be same. It will be different, surely different. There will be at least few more people in this category where the body fat is beyond satisfactory level. Question number 6. The histogram shows ages of people using fitness center at the Sports Science Institute after 5 p.m. in the evening. After 5 p.m., the number of people who actually visit the fitness center is given and the frequency density is given. Copy and complete the frequency data for this 0 to 15, 15 to 25, 25 to 35, 35 to 14, 40 to 70. See this 0 to 15 is here, 10 was here, 15 is here, and this is slightly less than 1. I think it is 0.8. So if this is 0.8 here, multiply by 15. So this will be frequency density is 0.8. Frequency density is equal to the frequency upon class width. Class width is 15. So 0.8 is equal to frequency upon 15. 0.8 into 15 will be equal to frequency. I think the frequency will be 12 here. Then 15 to 25 again. See this. This is 6.6 I think. 6.6 multiplied by 10, 66 here, frequency will be 66. And then you can fill in so on. I think this exercise is pretty simple and following the obvious pattern of what we are discussing and what we have discussed so far. So I'm not going to go too much in details with this. I want you to solve. Should there be any problem, of course you can come back and message me. We'll talk about cumulative frequency and cumulative frequency diagrams now. What is cumulative frequency? There are two things in my real life experience which I think are cumulative. One is fear. When I was very small, I was not scared of ghosts at all because I never had any such experience where going into a room can be scary. There was nothing. I never had any such experience. So there was no reason for me to be scared of ghosts. But somehow, somebody, maybe my friends or somebody started to tell me, there are, don't go to that room, it's dark and ghost there, what if there is a ghost? I did not have much fear about it. But then there was a little bit of fear that I sensed in my friends who were talking like that. So I could sense a little bit of fear and that had an influence on me. Later on, the more I read about ghosts, the more I talk about it, the more I hear about it, the more films that I might have watched, which are ghost stories or those kind of films, it started to have more and more and more and more effect on me, and I think the fear accumulated in a way. And after some point, I felt completely overburdened by that fear. The fear and pain are two things which get accumulated. So, if you taunt someone in the morning, the next morning you again taunt the same person, the third morning you will do that again. Eventually the guy will scream at you, because with every little taunt, you're giving a little bit of pain, and the pain just adds on to it. The meaning of the word cumulative is something that is accumulated over and over and over and over. Let's see this. It's very simple then. The scores out of 10, there are so many scores, 3, 4, 5, 6, 7, 8, 9, 10. There is no score of 1 and 2 or 0, because obviously whichever be the class that the test has happened in, the students, no one got 2 marks out of 10, no one got 1 mark out of 10, no one got 0 out of 10. So this entry is not there. 3, 4, 5, 6, 7, 8, 9, 10. Of course, 10 will be the highest and 3 is the lowest. The number of people who got 3 are 4. Number of people who got 4 marks are 5 people. 3 people got 5, 3 people got 6, 5 people got 7, 7 people got 8, 2 people got 9, and one student got 10. Total is 30. Now we talk about the cumulative frequency. Cumulative frequency, take the first frequency as it is, then add the next frequency to it. So 5 plus 4 or 4 plus 5 is 9. Then 9 may add 3, 12. Add next 3, 15. Add 5, 20. Add 7, 27. Add 2, 29. Add 1, 30. So this is what cumulative frequency looks like, and this is how you calculate it. You don't have to write this plus this, this plus this. This is for your explanation. If you are calculating cumulative frequency, just calculate 4, 9, 12, 15, 20, 27, 29, 30. That's it. Find the cumulative frequency. This is the first cumulative frequency will be 20. We'll just solve it here. So we'll write CF here. CF stands for cumulative frequency. 20, 60, we got this. See this. This is calculated. Determine which class interval contains the median height. What is median? The total number of people is 250. 250 divided by 2 is 120. Let's calculate this. I'll not just talk about this. So the value of n is equal to 250. N by 2 is equal to 125. So where will 125 come? The cumulative frequencies are 20, 60, 120 and then 200. So it is here that this value 125 is crossed. We are interested in that class in which the value 125 is getting crossed. So the class is 15 to 25. And that is why the answer is the median class. So the median height must be 125th and 126th floor. If you look at the cumulative frequency, you can see that it will be 15 to 25 the class, where 125, the limit of 125, 126, that those values, those numbers are crossed in this region. Up to this, there are only 120 entries which have been encountered. But in this class, 125th and 126th entry is encountered in this class. So the class 15 to 25 is the class in which the median can be found. This is called as median class. Cumulative frequency curve. This is the class mark. Show the frequency is given. We'll first have to find out the cumulative frequency and then we'll plot it as on the graph. Let's see this. Draw a cumulative frequency, then estimate the median mark. We'll do that. 1 to 10, frequency is 3. Then we'll add the next one. 3 plus 7, 10, 23, 52, 96 and so on. And finally we reach 300. Now we'll draw this. So for starting from 1, these are the numbers which are greater than 1. 3, no, less than 10. This is less than kind of cumulative frequency. So less than 10 is 3 people. Less than 20 will be 10 numbers, 10 such numbers. How come less than 20? Less than 20 can be 11 to 27. and 1 to 10 also less than 20, so 3. So this is total 10. Less than 30 will be 23. So we are going to plot these numbers on x-axis, the right hand side, not the left hand side. 10, 20, 30, 40 on the x-axis, and these numbers on the y-axis. So we have this on the x-axis, 10, 20, 30, 40, and plotted with this. Huh? Initially see, when the first number 0 is taken, even the cumulative frequency is 0, because the third number comes here, 3. And then you just join them and you get this kind of a graph. You always get this kind of a graph. It is looking like a slightly distorted S. It will always look like a slightly distorted S. S would be like this, but this graph looks like this. The median in the middle. So A, the question A's answer was frequency table. We have prepared the cumulative frequency table. B, construct a cumulative frequency graph to show this data. We have constructed the cumulative frequency graph. And C is calculate an estimate for the median mark. Estimate the median mark. How many total are 300 free? There are total 300 entries. The median value will be divided by 2, so 150. So take out 150 from the cumulative frequency side, make a horizontal line that hits upon, that touches or that intersects the graph, and wherever it intersects, from there take a vertical line on x-axis. Find out the number. The number here is 58, I think. So we'll say 150, 58. The median mark is 58. It is expected that the median mark would be 58. This is not exact, it's an estimate. Okay. This is the cumulative frequency. Total number of students. How many total number of students are there? 60 students are there. Answer 50 is 60. 50 the case. Sorry. Not this value. Only up to 50 the graph is going. So the total number of students are 50. The median journey time. Divide 50 by 2. 25. 25 कहाँ पे? Where is 25? 25 is here. 20 and 30 के बीच में इधर 25. So from here, draw a line. Take the line here. This is 38, I think. The median journey time is 38. See the number of students who took less than 10 minutes to get to the school. Less than 10. 10 minutes here. And how many are falling less than 10? Up to this point, check this. This is 4 students. So the answer is 4 students are getting less than 10 minutes. Then the number of students who had journey times greater than 30 minutes. कहाँ है? 30 minutes यहाँ पे. Greater than 30. So less than or equal to 30 will be यहाँ से आते और ये है 28. No, 18. Sorry, 18. Total is how many students? 100 students. Out of 100 students, 18 students are taking 30 minutes or lesser. So 100 minus 18. Oh, 50 is it? Oh yeah, sorry. This is in minutes. Sorry. The number of students is 50. Out of 50, 18 are taking 30 minutes or lesser. So more than 30 minutes would be taken up by the remaining students. How many remaining students? 50 minus 18 is 32. 50 minus 18 is 32. And the number of students who took between 40 minutes and 1 hour. 40 minutes and 1 hour. 40 to 1 hour. 40 यहाँ पे draw a vertical line where it cuts the graph. From here draw a horizontal line. We reach here. So this is 28. And this 60 से यहाँ पे बना के ये आएगा 42. 42 minus 28 is 14. This is the answer. Well, now the exercise you can help yourself, and should there be any doubt, please tell me. Quartiles we'll just see. The quartiles are divide the entire given thing into four quarters, equal parts. We'll see it here. This is the frequency, cumulative frequency diagram, and there are 0 to 64 entries here, 64. Now we divide these 64 into 4 equal parts. 64 upon 4 is 16. So para 0 to 16 will be the first quartile, 16 to 32 will be the second quartile, 32 to 48 will be the third one, and 48 to 64 will be the fourth one. So we are defining three major quartiles, three major intervals. Please pay attention to this. What I am saying is, what we are talking about is, we are dividing the total number of students are 64. I will draw 64 here. This is 0 and this is 64. And I am dividing this into 4 equal quarters. So this is half, half of half, half of half, 4 equal parts. So to divide this interval into 4 equal parts, I need 3 landmarks. This is 1, 2 and 3. So if I mark 3 points equidistant, then I get 4 equal quarters. So the important quartiles are 3, lower quartile, second quartile and upper quartile. This normally is given as first quartile, second quartile and third quartile as well. But because on a frequency diagram, the first quartile is shown lower, it is always lower. That's why it is also called as lower quartile. The one which is upper, the third quartile is upper, so it is called as upper quartile. And the second quartile is called as second quartile, which is the midway mark. So we can just easily get the the values of quartiles and then appropriately solve the questions. There is nothing great. Interquartile range, this is one of the important parameters, because what can happen is, if you are talking about the data, please pay attention to this now. If you are talking about some kind of a data, and I will show you a diagram for this. So this is what our cumulative frequency graph will look like. It is possible that some of these values might be too high. Let's say we are talking about the income of certain students' parents, the parents of certain students and their income. Now it is possible that I am teaching some of the students who are coming from fairly good rich families, but decent earnings families, but there are 4 students who are they are kids of industrialists. So if most of the families are earning, let's say 5 million to 10 million, 50 lakh to 1 crore rupees every year, there are 4 families who are earning more than 10 crore every year. Now on this graph, the highest ones will come here, but these values are just too high. If we are interested in the major chunk of the data, then the lowest 1/4, lowest 25% and the upper topmost 25%, the lowest can be too low and the topmost 25% can be too much, too high. It is always in between that half, that 50%. It is where the most significant part of the data and all the important analysis जिसका किया जाता है, that significant part of the data lies in this section. So we are trying to say that the first 25% are gone and we reach Q1, the lower quartile. Then after 50% is elapsed, we reach 75% mark, that is where Q3, the upper quartile is there. And the difference between Q3 and Q1 is that range where the major important chunk of the data can be found. And that is why this interquartile range is an important parameter. So people are going to ask in the examination, find IQR or find interquartile range. That is the difference between the upper and lower quartile. But why do you need to find that? Because the upper part and the lower part can have extreme values. But the moderately, correct value, correct data can be found in the Q3 minus Q1 region. That is the half of the data, and which is the data which is actually centrally located. Solving problems are just, they're just too simple now. This is the graph. We see that the cumulative frequency is going from 0 to 1000. Now, first will be 250, second will be 500, then there will be 750, and then 1000. So Q1 will be at 250, Q3 will be at 750. We are asked to find out the median score. Median score, middle value 500. From 500, draw a horizontal line. Wherever it cuts the graph, from there draw a vertical line, and you get the median. The median is coming at 30. Q1 is coming at 10. Q1 is 1000 divided by 4 is 250. From 250, draw a horizontal line. Take the vertical line from here, you reach 10. Okay. Q3 750. From 750, draw a horizontal line. Take the line here 90. So Q1 का वैल्यू है 10 और Q3 का वैल्यू है 90. अभी अपर क्वार्टर है 90 पे, लोअर क्वार्टर इज एट 10. Interquartile range is 90 minus 10 will be equal to 80. Yeah, the lower quartile is at 10 marks, upper quartile is at 90 marks, and the interquartile range IQR is 80 marks. Percentile, if you are dealing with large amount of data such as examination results for a complete country, or the average height and the mass of the students in different age groups, then we tend to divide the data into smaller groups which are called as percentiles. The position of a percentile uses the formula Pn upon 100, where P is the percentile that you want and N is N is how much data you have, and that is divided by then 100. So the worked example is, let's see, the above example is what we are taking, and we are finding out P10. So the percentile for the 10 marks is P10 is equal to Pn upon 100. What is P? P is the value 10 here, so 10 multiplied by the total data was 1000 upon 100. So 10 into 1000 upon 100 is 100. If you are talking about 85th percentile, मतलब the position is 85. So 85th percentile will be the value of P will be 85. N is surely 1000. See this. N is the number of the highest cumulative frequency, or the number of values. That is 1000. So we will put the values here. 85 into 1000 upon 100. So that is 850. And you get this. And then the last exercise will be having the same thing, but the questions will come as quartiles as well. So you are finding out IQR, you are finding Q1 and Q3, and then you also asked to find out the, use the percentile as well. I hope this helps. I hope this will solve the doubts. Please study the chapter. It's a very, very simple chapter, very easy. You can get it very easily. And if there is any doubt, please reach out to me. I will be happy to solve your doubts. Thank you.